9. So this problem is going to be much harder than other still game problems, because definitely it's really difficult to find intuition of how to solve the problem. We have to analyze all different cases. So Alice and Bob continue play with the game, and there's an array of stills, and there's going to be an associated value. And Alice and Bob take turns, Alice starting first, and on each turn, the player may remove any still from the stills. So it means the player can remove any stills. The sequence doesn't matter. So the player who moves a still loses if the sum of the values of all removed still is divisible by 3. Bob will win automatically if there are no remaining stills, even if it is Alice's turn. So what is the meaning for this part? It's going to be a little bit difficult to understand. So what about there is only one still, it is 3. So Alice is going to start first, and this 3 is divisible by 3. So if there's only one still, it is 3. The player who removes a still loses if the sum of them. So Alice will do it, and it is this one is removed, and it is divisible by 3. So definitely Alice gonna lose. So Alice gonna lose the game. Yeah. So if there's only 1, 3. Yeah. But if there's only one number, it is 1. Yeah. So Alice gonna start first. Alice gonna get a score of 1, and then it turns to Bob, but there's nothing for Bob to remove. Yeah. So Bob will win automatically because there are no remaining stills. There's no stills, it is empty, so Bob will win automatically. Yeah. So the problem is that we just need to check whose value gonna be divisible by 3 first. So if Alice's value divisible by 3 first, Alice gonna win. If Bob's value divisible by 3 first, so Alice gonna lose. And if Bob's value divisible by 3 first, so Bob gonna lose. Yeah. And if neither of them gonna divisible by 3, maybe it is just have 1, 1. So definitely Alice will lose and Bob win. Yeah. So this is the definition of the problem. So there are so many different cases. Maybe we just need to check one condition. We just need to check what is the condition for Alice to win the game. We need to check the condition for Alice to win the game. So we will ignore if Alice lose or Bob win or Bob lose. We just need to check if Alice can win the game or not. So if Alice can win the game, we're gonna always return true. Otherwise, we're gonna return false. So we just check one condition. Otherwise, it's 2 math testing cases. And another intuition is that the numbers are gonna be really big. So for example, 6 and 3, or maybe 2 and 7. Yeah, the numbers are gonna be really big. Do we need to sum up all those numbers, and then we're gonna try to check? So how many different numbers? It's gonna be really big, because the array is 10 to the power of 5, and the stills maximum value going to be 10 to the power of 4. It's going to be really big. It's really difficult to analyze. Yeah. So if 2 plus 7, it is 9. 9 is divisible by 3. Yeah. And modular 3. 9 modular 3. So it's going to be 0. And what about with divisible modular 3 first? So this is going to be 2, and 7 modular 3 is going to be 1. So this is going to be easier. 2 plus 1, 3 modular 3, it's still going to be 0. So what about this one? 6 modular 3, 0. 3 modular 3, 0. So 0 plus 0 modular 3, it's going to still be 0. So we don't need to use so big numbers. We're going to just use the numbers from 0, 1, and 2. First of all, we're going to turn all those numbers to 0 and 1 and 2. And then we're going to count how many numbers of zeros, how many 1s, and how many 2s. So this is going to be the first step and the first intuition we can find. Yeah, and then maybe we're going to use this 1 and 2 or 0 to construct a solution. So what about, yeah, we have a result. We have a count array. It's going to be 0, 1, and 2. We don't know how many numbers of 0, 1, or 2. It doesn't matter, but we're going to construct the problem. So for Alice, if Alice were to play optimally, if there are zeros inside, can Alice choose 0 first? No, because Alice will lose the game directly. So Alice cannot choose 0 first. Yeah, but what about if there's no 1 to only 0? So definitely Alice will lose the game, Bob will win. But we will not consider like that. We will only analyze in what condition Alice gonna win. Otherwise, there will be too many cases to analyze. We just analyze what kind of condition Alice gonna win. If Alice can't win, so it means Bob gonna win the game. So first of all, we cannot choose 0. Yeah, even there's a 0 inside for Alice, Alice will not choose it. We're gonna just consider the situation Alice gonna win. So what about Alice just to choose a 1? So for Alice, this is Alice. Alice gonna choose a 1 first, and then there are many 1, 2, and 0. But what about for the Bob? Yeah, so this turn for Bob, can Bob choose 2? No, Bob will play also optimally, so Bob definitely gonna choose 1. If there are so many 2s, for the next turn, Alice definitely gonna choose a 2, because 1 plus 1, 2, this is 4, modulo 3, it is more than 0, so it is okay, not equal to 0, it is okay. Yeah, and how many 1 and 2s we're gonna continue? So they're gonna be, yeah, let's just define it as k. Yeah, as k number, let's define it as n. It doesn't matter, but there definitely gonna be a lot of zeros and ones. Yeah. So definitely there gonna be a lot of 1 and 2s. Yeah. But what about the next? If we have already used up all those 1 or 2, so what left behind? Maybe there's nothing. Yeah, but if there's nothing left behind, definitely Alice gonna lose the game. But we will not consider like that. We will consider only Alice win the game. So if Alice still want to win the game, so this is for Alice, and this is Alice and Bob, and the next turn, yeah, this is Alice, and this is Bob and Alice, and the next turn from here, it's gonna be Bob. Yeah. So, but what if there's a number of 2? Definitely Bob will lose the game, because 1 plus 2. Because in between it is 1 plus 2, it doesn't matter how many of them. But here, definitely there's a 1 plus 2, it's gonna be 3. And 3 is modulo 3 equal to 0, definitely. And Bob will lose the game. In this situation, definitely Alice will win. Yeah. So this is one testing case. This is for 1. Another is what about Alice choose 2 from the beginning. Then inside it's gonna become 2, 1. Definitely it is not 1, 2. Yeah, if they play optimally. And Alice, in order to win the game, so at this position, Bob must choose a value of 1. So in this way, it means Alice definitely can win the game. Yeah, but how many zeros in between? And for this kind of situation, it must be even zeros. If there are 2 zeros or no 0, it is okay. Because if there's 3 zeros, this rule doesn't work. Yeah. So this means the count of 0, for the count of 0, if it is even, so if it is modulo 2 equal to 0, if it is modulo 2 equal to 0, so this means the count of 0, a 0 count, if it is even, so if it is okay. Because if there are 2 zeros, so Alice will use a 0, it is okay. Bob will use another 0, it is okay. We can put the 0 in between, it is okay. Yeah. And then after that, if there is a 2, definitely at this turn, Bob will choose this 2. And in this way, Alice will win the game, because after that there may be too many 2s, but there's no 1s. So Bob has to choose a number, and this number definitely gonna be 2. Yeah. Another one is for Bob, definitely gonna choose 1, because there's no 2 and only 1 left behind. Yeah, so this is in one case, this means the 0, the number of 0 is even. If it is even, so we're gonna check how many 1s and how many 2s. So how many 1s? As we can see, the number of 1s gonna be more than and equal to 1. and the number of 2's gonna be more than yeah, let's just use it this way. So let's say the number of 1's gonna be equal to k, and this k gonna be more than and equal to 1. And what about the number of 2's? The number of 2 are gonna be more than and equal to k, and our k is starting from 1. Yeah, so number of 1's gonna at least have one number of 1, and for number 2 it's gonna be more than the number of 1's. So for example, if there's a 1 1, so for 2 it's gonna be 2 or 2 2 at least. Yeah, and for the second case, so for the number of 1's, so for the second case there's more 2's, so for the number of 2's it's gonna be at least 1, it's gonna be k at least 1, but for the number of 1's it's gonna be more than and equal to k. So this is our first condition. The first condition is the count of 0 is even, and the number of 1's is more than 1. Yeah, and the number of 2's is also more than 1. As you can see from the condition, this number of 1's is more than 1, and here number of 2. From here, this number of 1 is more than k, number of 1's is more than and equal to 1, and the number of 2 from here is also more than and equal to 1. Yeah. So this is the first condition. If the number of 1 and 2, both number of 1 and 2 is more than and equal to 1, definitely in this condition Alice is gonna win, because we calculated it like that. Yeah. So at least we have a 1 and maybe 2 2's. Another is we have a 2 and maybe 2 1's. Yeah, or maybe it is just 1 and 2 or 2 and 1. It is still okay. Yeah, so in this case, we're gonna just check the count of 1 more than and equal to 1, and count of 2 more than and equal to 1, and it should work. Yeah. Now we're gonna go to the second condition. The second condition gonna be if the count, yeah, we're gonna still do it like this. For this is number 1, and for the Bob, it's gonna choose 1 2, and there will be a number of 1 2's, and for the next. But what if we have an odd number of 0? Yeah, even we have a number of 2's, but we have an odd number of 0. What are we gonna do? So this is for Alice and Bob Alice. Yeah, and this is for Bob Alice, and this is for Bob. Yeah, even there's a 2, but we have a 0. So definitely for Bob will not choose 2 directly. Bob will choose a 0 because we have an odd number of 0. Yeah, let's just imagine there's only one number of 0. So for Alice, what Alice can do? Alice can choose a 2. Alice can choose a 2 definitely. But in this way, Alice will lose the game directly because 1 plus 2 is 3. So this means Alice cannot choose 2. What about Alice want to win the game? So Alice definitely gonna choose a 1, and Bob will choose another 1. This is Alice, and this is about Bob. Yeah. So this means the number of 1's, minus the number of 0's. So this means the number of 1's minus the number of 0's must be more than and equal to 3. As you can see, 1, 2, 3 of 1's, and after that 1 and 2, there's no 0's. This means the number of 1's minus the number of 0's must be more than 3. Or there's another case. What about Alice choose 2 first, and inside we're gonna have 2 and 1, and how many of them? There will be n of them. And then after that, this is Bob and Alice and Bob. Yeah, so what about Bob choose? Bob definitely will not choose 1 because it will lose immediately. So Bob gonna choose a 0, right? So if Bob choose a 0, so what Alice gonna do? Alice gonna choose a 2 definitely because 2 plus 2 is okay. And then Bob choose another 2. Bob will lose the game. Yeah. Or maybe there's another one. Bob gonna choose a 2 first, it is okay. But can Alice choose a 0 or 2? Alice choose a 2, loses the game immediately. But Bob will not do that. Yeah, because Bob cannot choose 2. Because if Bob choose a 2, Alice gonna choose a 0. And Bob choose a 2, Bob will lose the game, as you can see from that. So Bob will not do that. Bob, if there's a 1 0, Bob will choose this 0 immediately. If there's a 3 0, odd number of 0, it is okay. 1 for Alice, 1 for Bob, but definitely there's a 0 for Bob. And then in this way, Bob will lose the game, and Alice will win. Yeah. So what about there's another one? I think there's another one. If Bob choose a 2, so Alice gonna definitely choose a 0. Yeah, let me just analyze. Did I do something wrong about it? Yeah, because it may make mistakes. So for the first case, that is 1 for Alice, and here for Bob choose a 0. Yeah, and this is 3. It is okay. Yeah, and there's another case. Let's just check it. And so for Bob, if Bob choose a 2, and Alice gonna choose a 0, and then Bob gonna choose a 2, so Bob will lose the game, because 2 plus 2 plus 2, 6. Yeah. And similarly for here, there's also another way. So what about Bob choose a 1 first? Yeah, it is okay for Bob, because 1 plus 1 is 2. But for Alice, definitely, Alice will not choose 1. Alice will choose a 0, because there's a 0 for Alice to choose. For the next, so Bob will choose a 1. So 1 plus 1 plus 1 is 3, so Bob will lose the game, so Alice will win. So for here, there are 2 cases, and here, there are also 2 cases. But the idea is the same. The number of 1s minus the number, this is not 2. The number of 2s must be more than or equal to 3. Here also the same. The number of 2s minus the number of 1 must be more than and equal to 3. So this is the second formula. Yeah. So basically, we're gonna use the first and second formula to solve the problem. Yeah. Now let's go back to the problem. We're gonna prepare a count. So this count is gonna be 0 times 3, because the length of the array gonna be 3. So we're gonna check the steals. So for s in steals, so inside the counter, it's gonna be s modulo 3 plus equal to 1. Now we have a counter for number of 0, 1, and 2. We just need to check if this count of 0 as our first formula modulo 2, it is equal to 0. Yeah. So if it is equal to 0, yeah, if this is equal to 0, we just need to check the number of 1s and the number of 2s. Number of 1s should be more than or equal to 1, and number of 2s should be more than or equal to 1. So in this way, this is our first condition, Alice is going to win. Another condition is if the count of 0 modulo 2 is equal to 1, it is odd, and we're going to use the absolute of count 1 minus count 2. It should be more than and equal to 3. So in this way, Alice is gonna win. Otherwise, so Bob gonna win. So it's gonna return a false. Yeah. So this is only the 2 conditions Alice is gonna win. Because if we analyze Alice win, it's gonna be easier. If we analyze Bob win, it's gonna be much more situations. It's difficult to check. Yeah. So this basically include all different testing cases. And while we construct the problem, yeah, according to the description, this is gonna include all descriptions. As you can see, this problem is not so easy, and we cannot solve it like the previous experiences. We have to analyze it as a new problem. We have to construct all different situations and generalize the solution. So, but I think there is also a way to practice. Yeah, maybe in Leetcode there's not so many this kind of a construct problem, but definitely this is a good idea to practice how to construct the problem according to descriptions and find some formula or generalize some formula to solve it. Now let me submit it to Zach. Yeah, as you can see, it works. Thank you for watching. See you next time.